Hi everybody, my name is Rosy Tchitembo and I'm a student at the University of Texas at Tyler. Today I'm going to make a video for one of my classes and my project, for this video was shell and tube heat exchanger. So the first question we can ask ourselves is what is a heat exchanger? Basically a heat exchanger is a device used to exchange heat between two fluids or more. So depending on the kind of heat exchangers we are dealing with, the fluid can be single phase or double phase. A heat exchanger can also be defined as a device designed to transfer efficiently the heat from one matter to another one. There are nowadays in the industries there are so many different type of heat exchangers, but today the one I'm going to be talking about is like a very known one, which is called a shell and tube heat exchangers. So the purpose of my project is to do two things. The first one is to design my shell and tube heat exchangers, and the second one is to talk about the two different approaches we can use to design it. So we have two different main approaches. The first one is the log mean temperatures, and the second one is the number of transfer units. Well, like I said before, a heat exchanger is a device used to exchange heat between two fluids and more. Here we have a picture of how like a simple heat exchangers, shell and tube heat exchangers. Here is another one. We have the tube outlet, we have the shell inlet, we have the baffles, we have the shell outlet, and the tube inlet. Those are for the inlet temperature and the outlet temperature. For the fluid, because one fluid goes into the tube and another one goes between the space. So, like I was saying, depending on the type of heat exchangers, we can have cold water, high pressure. The shell and tube heat exchangers are one of the well-known shell and tube exchangers. Shell and tube exchangers are one of the well-known exchangers because of the advantages. Like they have so many advantages compared to other shell exchangers. Um, Sometimes the design of shell and tube are like very difficult because of the complex characteristics of heat transfer and pressure drop. So the goal of the heat exchanger is to correlate with the inlet and outlet temperature. Basically, we can notice the difference between the inlet and the outlet temperature. There is always a huge difference between the inlet, like the temperature we have at the beginning, and the outlet temperature, which is the temperature we have at the end of the end. So with the log mean temperature, like I mentioned, this is like the main equation we use, with delta T2 being the difference of temperatures at the outlet or inlet, and delta T1 is the same thing, the difference of temperature at the inlet or outlet. We have the number of transfer unit, which is our second method, and this is the main equation we can use for it. Whenever we design our shell and tube extenders, there are so many factors we can take into consideration. And here we have like the main important point of our shell and tube extenders. We have a shell, which can be described as the container for the shell fluid, and the tube bounder is placed inside the shell. The second one is the tube, which is designed as a compact heat exchangers, and the the dimension we use for that one is 3/4 and 1 inch. The tube passes. Basically, the number of tube passes is chosen to get the required tube side fluid velocity to obtain like a great heat transfer coefficient, and also reduce the scale formation. The next one is the tube sheet, which is most of the time made with flat piece of plate, you know. And in another word, it is a plate which is used to carry the tubes in the shell and tube heat exchangers. The baffles. The baffles are very important, like very important, because they are used to carry tubes and they prevent failure of tubes due to vibration because like shell in tubes vibrates a lot. So the baffles helps the tube to not move a lot. Here we have some basics equations. We have question for heat transfer. For heat transfer, we have the Nusselt number. We have the formula for the number of transfer unit. We have the formula for the Reynolds number. We also have the formula for the log mean temperature we already talked about, the baffle spacing, and so many other equations. Here is a picture of shell and tube heat exchangers. And in conclusion, we can say a shell and tube heat exchanger is one of like the very known heat exchangers because of some advantages, like in terms of the pressure drop, the heat exchangers. Shell and tube heat exchangers consist of series of tubes. One set of these tubes contains the fluid which must be either heated or cooled. The second fluid runs over the tubes which are being either cooled or heated, and the second one basically provide the heat or absorb the required heat. So this is the end of my video, and thank you for watching.